presentation. So I want to welcome everybody to the second part of the two-part series for the Council on Forest Engineering Temporary Steel Bridge webinar series. The series is hosted by the New England Regional Council on Forest Engineering and the Short Span Steel Bridge Alliance. Last Friday, we had two presentations on temporary steel bridge structures. If you missed them, you can use the link that I show there in blue, if you can write that down really quickly, or I'm sure Ray from the Northeast Coffee will post that in the chat here very soon. Ray is the coordinator for the Northeast Coffee, and he will now introduce himself and explain the PDH system for the series and how to see the recorded webinars. Ray?
Thank you, Michael. As Michael said, my name is Ray Berthium. I chair the New England Region Council on Forest Engineering. That link that you see there, yes, I'll type that in to the chat as we move forward here. And that link provides you the video from last week, as well as an attached survey that will then send me the information that I need in order to send you a certificate. We have been awarded one Category 1 credit hour from the State of Maine Bureau of Licensure and the SAF for forester license credits. But I can, if you need one of those certificates, we're happy to send you one of those. And I believe most other places will be able to, foresters can use those in their respective states. I had somebody last week ask about a PE certification, and I'd be surprised if they don't accept the certificate that we provide. But let me know. I'll give you in the chat, I'll give you my email address, and anybody that, in addition, I'll give Cindy Pascal's email address in the chat, who is actually the one that will send out the certificates. Thank you all for participating. Michael and Dan, thank you for working with me on putting this on. And with that, Michael, I'll be quiet and just pay attention to what we talk about today.
All right, thank you, Ray. So as moderator for today, my name is Michael Barker, and I'm a professor of civil and architectural engineering at the University of Wyoming, and I'm also the director of education for the Short Span Steel Bridge Alliance. I'm showing you a slide here on how you can keep learning about steel bridges. I encourage you to visit the shortspansteelbridges.org website and just explore how the Short Span Steel Bridge Alliance can help you in your bridge infrastructure needs. Now, last Friday, I had an opening statement, and I'm going to repeat it here today. We know that bridge designers, fabricators, erectors, and contractors have always been innovative in delivering steel bridge projects for owners. They can deliver high quality, beautiful bridges that are economical, durable, and very effective for tough build sites or accelerated bridge construction. Now, during the presentations, feel free to submit questions through the chat. Also, and this has worked very, very well in the past, feel free to respond to each other's comments or their questions in chat. I will be monitoring the chat so that I can kind of collate the questions and we can ask the presenters the questions at the end of their presentations. And with that, we will get right into our first presentation for today. Glenn Roby is the Contech Engineered Solutions Bridge Consultant responsible for Maine, New Hampshire, and Vermont. And I'm just going to let Glenn introduce himself and his presentation. So with that, I'm going to stop sharing. Glenn, you start your share and remember to hit that with computer sound and we will get you going.
There, can you see my opening?
That is perfect.
Okay, excellent. Well, good deal. Let me, I've got one more screen I think I need to pull up.
Well, you were perfect. Now it's not. There, you're back.
I'm back. Well, it's kind of funny. This is a little different than it was in rehearsal. So we'll. There, we still on?
Yep, you're all good.
Okay. First and foremost, want to thank everyone for joining today's presentations and for the short span steel bridge alliance for putting the trainings together. I think it's a terrific opportunity, hopefully, for everyone to learn something new and or see something that might be a little different than what they've seen in the past. My name is Glenn Roby. I'm the BC for Maine, New Hampshire, and Vermont for Contech Engineered Solutions. I was a market manager with Big R Bridge when they were acquired by Contech in 2019. And I've been between the two companies, I've been in the bridge market for over 10 years. Prior to being in the bridge industry, I spent over 10 years in the precast market, servicing both bridge and retaining wall needs among other products. And my role as a bridge consultant is to support your design, your site-specific designs, as well as construction of various products. Let me know how I can assist, no matter what stage your project might be in. Got about a half hour, so let me get started. Someone may ask you if you're interested in an apple, and you may be thinking you're going to get a Red Delicious. And as with many things, there are lots of different choices. And the reason that we want to make sure we're very clear on what we specify. And when we're looking at a stream crossing, the pipe on the right, which was likely reclaimed from a paper mill at some point, may have been a perfectly acceptable solution for a water crossing. But now aware of stream smart design, ensuring ecologically appropriate crossings, as well as limiting maintenance that may stem from undersized structures, we look at options that serve both goals, such as this modular bridge, which was installed very quickly, as well as very economically. Michael, do you have my...
Glenn, okay, so are you trying to advance your slides?
Yes, I am.
Oh, there's your apples. There's your pipe. Okay.
Okay, I've got apparently the screens aren't lined up the way they were the other day. So my apologies.
We're back on track.
Okay, so here's our pipe that was pulled from likely a paper mill. And here's our modular bridge, which obviously is appropriate structure selection for the same stream crossing. I'm going to run through rolled girder modular bridges, as well as some bridge options, touching on design, fabrication, installation, some abutment information, including bin wall and MSE wall, as well as some plate structure information I hope is new to you. When considering any bridge option, design is key to a successful project. Following AASHTO National Standard LRFD design methodology using current HL93 loading, as well as owner-specified vehicles, you're confident that the bridge will meet its site-specific loading needs. Incorporating test-level guardrail, also meeting AASHTO standards, show consideration for this design element, not leaving it to an arbitrary based on what someone may think is sufficient. Annual certification, fabrication certifications, endorsements ensure you're getting what you pay for in a safe, reliable structure on your project. Fabrication certifications from AISC range from SBR, approved for weld of unspliced rolled girder bridges, up through ABR, advanced major, approved to fabricate vehicular bridges that require more sophisticated care for fit up regarding geometric tolerances. Without proper design and fabrication, even the best crossing layout is incomplete. So I encourage you to make certain that your structure on your site meets federal standards. I'm going to go through a two-piece modular set, the use of precast sills, a stone bed detail, bearing assemblies, limited bolted connections, as well as impact rated guardrails. This precast sill is usually 30 inches wide, 18 inches deep, and varies in width depending on deck width. And you'll see from this cross section an isolated stone bed underneath a precast sill. Always a good idea to provide a well-compacted, well-drained material under a sill so that we know that frost is mitigated and that the sill is set on good soils that can be easily leveled, truing up the foundation. As with most remote locations, modular bridges are usually installed using very light equipment. As you can see, 2 backhoes, one from either end of the bridge, setting this module onto precast sills. I'm going to share a case study, this one on a heavy haul road. Many of you are probably very familiar with the Stud Mill Road. And this project over Allen Brook had several challenges. The meandering stream skewed underneath the roadway, and the long span was required to accommodate that skew and be low profile. And with the many players involved, it was very important that federal standards for design were met. So for that reason, the modular bridge was chosen. And with these projects, per typical, the bridge modules being loaded on and brought in on a flatbed truck, often stacked up. And then the site is prepared with natural stream bottom, the natural stream bottom with precast sills in the background. And the precast sills have bearing assemblies which provide connectivity between the concrete foundations and the bridge beams themselves. And there you can see the backhoes positioning the modules into place. And underneath the structure itself, mid-diaphragm splices which use a 4-bolt connection, usually in 3 positions. And then up on the deck, you'll see the small red arrows pointing out mid-deck splices, bolted splices. And on the right, the large red arrow shows the side dam, which extends up over the structural decking, at least 3.5 inches. And that side dam is really there to capture a wearing surface for the structural deck. Wear surface most frequently being gravel or timber running planks or direct pave or concrete. And here we see in profile a precast sill with the bearing assembly, guardrail posts, and then sheet pile back wall behind the bridge, retaining the fill from the ends of the bridge. Underneath the structure, we'll see the bearing assembly, which connects the bottom plate to the precast sill below, as well as the bottom flange of the beam to the top plate of the bearing assembly. This ensures uniform load being brought down through the foundations for good long-term performance. And looking across west on Stud Mill Road, the gravel wear surface in place and a TL3 guardrail. And since the Guardrail is flush with the outside of the deck. The entire travel area is usable compared to, say, for instance, Jersey barriers. Running planks, another very common wear surface. These are oftentimes factory installed. So when the bridge is set, the structure is ready for immediate traffic. These timber planks could easily be a full width wear surface. And you may see at the top of the image that holes have been left in the decking. And these holes have been left where the pick points are, so shackles can easily be set in and the structure be moved to an alternate location. We certainly realize that a impact rated guardrail is not always the best option for a specific site. For instance, a blueberry operation that may have some very wide equipment that hangs over the side. And so these timber curbs, which through bolt through scupper blocks to backing plates down underneath the bridge deck, make a very stout arrangement and possibly a good option for your site. Now I want to pause for just a minute and speak a little bit about different coatings and options that you may want to consider on a project. It was weathering steel was discussed last week, and Core 10, which is the brand name for weathering steel, develops a hard protective patina on the outside through a series of wet and dry cycles. And with that, the protective patina makes weathering steel a low maintenance option. It also might be considered a green option as there are no coatings to leave at the project site, and also has quite an impact since it's the lowest cost option. Painted steel. All of Contex's bridge facilities have proper preparation for coating with an SP6 or SP10 blast, as well as sophisticated paint endorsements. But it's important that if specifying painted steel, that proper prep and coating is indeed what you get. Galvanized steel, certainly the highest quality, and very interested to learn more about that in the next presentation. But galvanized steel does have some limitations, and depending on span, perhaps the bridge may need to be broken down into smaller components. And with that, there may be additional field assembly, and or there's certainly a cost associated with galvanized steel. So when we think about where weathering steel is going, we like to think about the environment. And since the icing chemicals and similar are what deteriorate weathering steel the fastest, and the remote locations that most of these projects are in, weathering steel may be a good option for you. As you see this tractor pulling in one end of the modular bridge under a zip line, and then the excavator pushing the far end out onto the far bank. As you can see, with no access, now there's quick and efficient access to the far side. Sometimes increased span is not sufficient to accommodate different grade changes. So looking at some different options, a galvanized riser beam on top of a precast sill may be a consideration. And this 2 or 3 foot grade change still accommodates the bearing assembly on top. Once we go up into larger elevation changes, we look for different options, such as this galvanized steel bin wall. And the bin wall, with its vertical posts and horizontal corrugated plates, are easily bolted together. And the isolated soil cells are often used in conjunction with local materials. with the ability to have wall heights excess of 20 feet. These bin walls can make an excellent choice, such as you see here, with precast sills already set on top and some excavators moving the first module into position. This local project in Blanchard Township, Maine, using the bin wall technology, as this Mariaville project did as well. Other options for foundations, and I believe Kathy referred to these wire-faced walls last week more generically as Hilfiker walls, have an L-shaped facing unit. The L return on the bottom connects to soil reinforcement units with a simple C-clip. These galvanized steel soil reinforcement units extend out typically 0.7 the height of the wall. So you might think about a 10-foot high wall having a 7-foot long strap length. The face unit for these wire wall systems are usually handled in one of two ways. For a more temporary application, a filter fabric is applied to the face. In more permanent applications, a stone material is on the face, separating the UV and protecting the UV nature of the filter fabric behind it. The wire walls installed at many geometric angles, and you can see it goes up very quickly. If the 2-foot tall units, if you were to count the 6 layers, you'll see that they're already up 12 feet. And then finished off with a precast leveling pad, as well as a modular bridge. Since these wire walls are very flexible from a geometric standpoint, they make excellent head walls for corrugated structures, such as this temporary bridge application down in southern Massachusetts, or a permanent application, this one on a Plum Creek project. And although cast in place concrete might not be well suited out 70 miles out the Golden Road, this particular 4x4 foundation was cast in a trench form. So the excavator pulled out the material, reinforcing was placed, the concrete was cast, and then a simple keyway was field cut after the fact. Deep corrugation profiles in structural plate provide very large spans up in the 80-foot range. And this 55-foot span plus was installed over a weekend shutdown. This first 2.5-foot long ring was installed about 9:30 or 10 in the morning. And throughout that Saturday, the rest of the 50-foot long plates were assembled. And at the end of the day, the structure was ready for final torquing, as well as field grouting to the cast in place foundation. The structure was open to traffic below, well ahead of the Sunday evening shutdown. Here you see it in service with traffic on top, as 2 field built conventional bridges were installed on either side. Another foundation option that might be a consideration would be a galvanized steel form with pre-tied reinforcement already installed. Footings that are all pre-sized specific to the job site, as well as having open bottoms, ensure that concrete has uniform placement and bearing on the subsoils below. In this case, a plate structure is set onto the prefabricated forms and then allows for immediate placement of concrete. The concrete not only fills the foundation form, but it also locks the plate structure into place. So very quick, very easy, very efficient, and ready for backfill. I provide this image to show from the top with very small structures. There are lots of steel options as we move through down in our modular bridges, as well as steel trusses. So lots of different options for lots of different projects. And as you think about a project that you may be working on, certainly don't hesitate to reach out if we can provide some additional options or insights that perhaps you may not have thought of. And with that, I'll see if there's some questions.
All right. Thank you, Glenn. That was an excellent presentation. Last week, I picked out one picture I really liked from Acro when they cantilevered that truss element bridge over that wide river. But today I saw a bridge installed on a zip line. That's pretty cool. That's pretty cool. All right. So I want to remind the attendees that what you saw today was from Contech. Great company. In fact, my son works for them, so I'm giving a little plug there, I guess. Last week we heard from Acro, another great bridge manufacturing company. I encourage you to go to shortspansteelbridges.org, where we have many bridge manufacturing firms that can supply you a quality bridge. And I encourage you to go and visit those. So we had one question from Randy. What was the span of the Stud Mill Road?
Geez, it's been a few years, but I think it was in the 50-foot range.
Okay. And then Sean from Contech did give some information on there where you can span up to 80 foot with a single piece and 140 when you put some splices in there. And Melissa will talk a little bit about the galvanizing side of it in a little bit, you know, as far as tub sizes for dipping those pieces. I'm sure she'll talk about that. Hera Sharon says, what thickness of fill on plate arch bridge was used? What are the design references or code use to design steel plate arch bridges?
That's a great question, and it depends in part on which plate material is being used, as well as the loading and soils around it. So traditionally, for deep corrugation profiles, similar to what you saw in the series of photos, it's usually a 2-foot minimum. There are other opportunities to reduce that, and certainly tremendous fill heights can be achieved over the structure. I assume that the question really points towards minimum covers, but able to accommodate lots of different options. And we're also able to accommodate different geometries that may change that as well.
Well, personally, I love those buried steel structures, those arches. As far as a county engineer, I would be looking at those because they're just gorgeous bridges. And I know I've said that in the past. Okay. Hera Sharon also says, if 2-foot minimum not possible, any other recommendation?
Yeah, so we can have a relieving slab, or we can also introduce ribs on the structure. So what I would encourage is, if he has a project specifics and wants to send those over, we might be able to change the geometry so it actually creates a lower profile structure. And that, in conjunction with some of these other items that I mentioned, may be a perfect fit. So just need some details to go with.
Thanks, Glenn. And Joel Ham, who's from our Big R Contech company, says that Section 12 of AASHTO LRFD bridge design specifications deals with buried steel bridges. And yes, Joel again says, if 2-inch minimum cover, if that's not possible, we can look at special design features or modify the geometry to fit better. Okay, Glenn, thank you very much. That was very nice. Melissa, you can start getting your presentation up as we finish Glenn out here.
Thanks very much, Michael.
Thanks, Glenn. That was great. I enjoyed it. Okay, Melissa Lindsley is the Executive Director of the American Galvanizers Association, and she's going to talk to us about galvanizing. And I'm going to let Melissa introduce herself and her presentation.
Great, thanks, Michael. Hopefully everyone can hear me and are enjoying their Friday. As those of you that were here early on heard, it's a wonderful day in Wyoming, which means it's also a wonderful day here in Colorado, where I'm based. You might be asking yourself a little bit about why would I want to galvanize a bridge that's a temporary structure? Because most people understand or know that galvanizing is commonly done to extend the life of a structure. But I hope as we go through today, you'll see some reasons why that might be beneficial even in temporary bridge structure. But before I get started, I have to make a quick comment about Glenn and Michael's discussion of the zip line installation of the bridge, which was pretty impressive. One of the other things that I'm not going to show today, but we had a bridge in Vancouver, I believe it was, that was put in, that was helicoptered in the pieces of the pedestrian bridge. So a lot of creative ways, I guess, to get a bridge into place if needed. Just a little bit about the American Galvanizers Association. If you're not familiar, we are a trade organization that has been around since 1933. And we just kind of provide a unified voice and expertise in after fabrication hot dip galvanizing. So our primary mission is really just education and guidance for specifiers, for architects, engineers, and other folks who are looking to use galvanized steel in their projects, and then provide some resources for our members when they join the association. Here's kind of the goal of my 20 minutes or so, is just to understand a little bit about galvanizing, to know why specifiers might choose to use galvanized steel, and then just show you some case studies of temporary bridge structures to understand why even in a temporary bridge, galvanizing might be beneficial. So to start, I just want to make sure that we all are familiar and understand the hot dip galvanizing process and what we're talking about here. So this is just a quick graphic that shows what the galvanizing process looks like. It starts with surface preparation that's done within the galvanizing or the galvanizer's facility, excuse me. There's three major steps in that surface preparation. Degreasing, which is going to take off organic compounds. Pickling, which is really the primary cleaning mechanism. This is a mild acidic solution that's going to take off all mill scale and oxides. Basically, when it comes out of that bath, it's at a near white metal clean. And then the final step of the surface prep is just a flux solution, which will basically do any final mild cleaning of contaminants on the surface since it was removed from the pickling bath. And more importantly, put a protective layer on the surface so no contaminants will basically form before going into the galvanizing bath itself. A little bit about the galvanizing bath. It's heated to about 830 degrees Fahrenheit. It's required to be at least 98% pure zinc. The 2% of additives, there are limits within this, but it is to the galvanizer's discretion. The most common that you'll see are aluminum, bismuth, and nickel. And these help with things like the fluidity of the zinc, the shine of the coating, and controlling the coating thickness. Basically, while it's in the galvanizing bath, it's going to stay in there until it reaches bath temperature, typically about 5 to 7 minutes. The kettle operator would know when the steel has reached the bath temperature because the bubbling on the surface would dissipate. And while it's in the kettle, there's going to be a metallurgical reaction between the iron and the steel and the zinc in the kettle to form the galvanized coating. And we'll talk a little bit more about that as we go forward. So what are some of the benefits of using hot dip galvanized steel in bridge structures? We're going to talk about kind of the 5 big ones or 6 big ones here, but I think we'll try to relate those into the temporary bridge structure as well. So as we talked about at the beginning, the biggest reason or the most common reason that hot dip galvanized steel is chosen is for its corrosion protection. And it really provides 3 levels of protection. It provides that basic barrier protection that basically any coating used would provide by isolating the steel from the environment. But more importantly, it provides cathodic protection, which basically means that the zinc is going to sacrificially corrode to protect the underlying steel. So basically, as long as there is zinc on the piece, it's going to corrode and prevent the steel below it from corroding, excuse me. But the real longevity of galvanizing comes into play with what's known as the zinc patina. And this is something that develops naturally as galvanized steel is exposed to wet and dry cycles in the environment. It produces a series of byproducts on the surface, zinc oxide, zinc hydroxide, and zinc carbonate, which will slow down the overall corrosion rate to about 1/30th the rate of steel in the same environment. So here's our first case study. This is an example of a galvanized steel temporary structure that was put up in Chicago, Illinois, just a couple years ago. This is a US bridge structure, and they put it in to replace a 1914 bridge that needed to be removed. Initially, it was put in as a temporary structure. In fact, they were able to deconstruct the old bridge and reconstruct this temporary modular structure within 3 months of the start. So all of that happened in a quick turnaround time. And now that the bridge is there and it's performing well and looks nice, they're actually discussing leaving this as a permanent structure. But the good thing about using galvanized steel on this particular project is that it provides that flexibility. If they choose to only leave this bridge in place for 5 years, it's ready for that challenge. If they decide to leave this bridge in place for 100 years, like the previous structure, it's also ready for that challenge. Another benefit of hot dip galvanizing is its durability. And there's kind of a few different areas within durability that really come into play. The first is its abrasion resistance. And this has to do with the fact that the galvanized coating is not just a surface coating on top of the steel, but basically becomes a part of the steel and is intermeshed with the iron of the steel. And this photomicrograph is showing that basically the layers of the galvanized coating are a combination of zinc and iron. So we're not just sitting on top, but we're now intermeshed with the steel itself. And that provides great bond strength, and hardness of the coating is actually harder than the steel itself. So very difficult to damage, very difficult to hurt the coating or cause any sort of damage that would allow the underlying steel to be exposed. This is an example, a little bit different than the first one. This bridge in Ohio was, again, a structure that had been in place for over 100 years, since 1913. They had to close it in 2010 because there was some corrosion concerns or structural concerns. And so in 2015, they took down the bridge, deconstructed the existing bridge, and hot dip galvanized it and put it back into place. They did make a few engineering changes because of differences in code, but a lot of the 100-year-old steel in the original bridge was dipped and reused in the galvanized or the new galvanized structure. So they didn't really have to replace the bridge. They simply reused the existing structure and added in the support that was needed to open this back up and preserve the historical significance of the former bridge. Another part of hot dip galvanizing's durability that's important to understand is that it provides uniform protection and complete coverage. And what do I mean by that? Well, basically, hot dip galvanized coating grows perpendicular to every surface of the steel. And so that means that any of the corners or edges will have the same thickness as flat surfaces. And any interior areas, if a hollow structure or threads of a coating, are going to be fully coated. So there's really no weak point for corrosion to begin or to attack the bridge. This is another great example of a temporary bridge that's likely to become a permanent structure, but all of us are aware of the Hurricane Maria that went through Puerto Rico a few years ago, and it wiped out multiple bridges around the country. And a lot of those actually cut off people from access to food and other necessities. And so it was very difficult and important to get these access ways opened back up as soon as possible. Once again, this was a US bridge project. and they were able to work with a galvanizer in Ohio, and they had the first modular bridge structures built, galvanized, and shipped down to Puerto Rico within 6 weeks of Hurricane Maria. And all of the bridges were replaced within 6 months of the tragedy. So as I mentioned at the beginning, a lot of the reason to use hot dip galvanizing is for its longevity. And even in the temporary structure, this could become important because sometimes our best laid plans don't work out how we expect. And maybe we thought the bridge was just going in for 5 years, but it could end up being there for 20 or 30 years, depending on the situation. So one of the advantages of using hot dip galvanized steel is that basically you pay for it up front, you put it up, and you can more or less forget about it. So if it's in a remote area that's difficult to access or anything like that, you really don't have to worry too much about maintenance or closing it down. This particular time to first maintenance chart that I'm showing you here shows kind of the life of hot dip galvanized steel in various atmospheric environments. And the typical, I guess the minimum coating requirement for galvanized steel for any piece of steel that's a 1/4 inch thick or greater is about 4 mils of zinc. So if you look at that 4 mil line and come up and look at, even in an industrial environment or an urban area, which is the most corrosive, you're looking at about 72 years before any maintenance is required. And that would be defined as 5% rust of the steel surface. So 95% of that bridge would still have some zinc coating on it at that point. Here's an example that actually is current from this year. This is an acro structure. It's 230 feet long. And the former bridge here was actually damaged in May of 2020 by some historic flooding in the area. And so they really didn't have a lot of choice. The area was closed off to traffic and they needed to come up with a solution quickly. So they worked with this modular structure to make a detour until they could decide if they needed to put in some other sort of permanent structure. So it was, construction began on December 1st, and I believe the bridge opened in February to traffic in the area. So once again, quickly able to put this modular structure together, put it up, and get traffic moving once again. Speaking about, or speaking with a group of folks that are involved in the forestry service, I know that sustainability is an important part of what you do and what you consider every day. And so one of the things that I like to talk about with galvanized steel is the environmental advantages that it provides. And one of the biggest things, or the thing that I like to start with, is that galvanized steel is made of natural and abundant materials that are essential to life. So zinc is the 24th most abundant element in Earth's crust, and iron ore is the 4th. So they're readily available to us and able to be used for this type of construction. But more importantly than that, they're both 100% recyclable without the loss of any properties. So you can basically use steel and zinc over and over again as steel and zinc, or a hot dip galvanized piece could virtually become a hot dip galvanized piece over and over again. And in addition to the ability to be able to do this, I think it's important to highlight the fact that it's not just something that's possible, but something that's done as a standard of practice. Steel is one of the most recycled materials in the world, and the reclamation rate of zinc is 80%. So 80% of all zinc that's available for recycling is actually reclaimed and put back into service. So I think this is something that shows that not just lip service, but this is something that we actually do in our industry. In addition to those two major environmental items, of course, that maintenance-free longevity that we just talked about also is a great thing for sustainability, because there's no VOCs or emissions or anything coming off of that bridge while it's in place. There's no maintenance, so there's no need to bring out vehicles or other things to come out there and disturb the environment while it's in place. If you wanted to get an idea of the life cycle of hot dip galvanizing, this is basically just an abbreviated version or abbreviated chart that shows you what you get. But basically, again, as I've mentioned, all of the raw material and energy input, or the environmental impact, if you will, is really isolated in the production of the bridge. When it's in use, there's usually no input for maintenance, no emissions coming out of it. It can just be out there for 75 or more years, and particularly in a rural environment for easily 100 years. A little bit of energy when you want to demolish the bridge or take it down, but otherwise it's just going to sit there and kind of do its job. And when you take it down, of course, 100% recycle, loop back into production, no waste of materials there. So I talked earlier about the Indian Mill Bridge, which was basically deconstructing and reconstructing a existing steel structure. This is a very similar type of project where all the bridge rails on this road in Michigan, which is also more famously known as 8 Mile Road, were removed after over 50 years of service. They were able to strip off the existing galvanized coating that still remained, re-galvanize them and put them back in service. And the Michigan DOT only had to use 20% new material in the entire project, which was the addition of the second horizontal rail that you see here. The previous version only had one horizontal rail. And the only panels that had to be replaced were due to vehicle damage and not to corrosion. So just a great example of being able to reuse steel over and over again for new structures. And then finally, there's a lot of versatility with hot dip galvanizing. First, it's important to understand that it's a factory controlled process that can be done 24/7, 365. There's fabricators located throughout North America ready to help service this and provide the coating. No really, issue with turnaround time. We don't have to worry about, temperature, humidity, or anything. We can just produce, as I mentioned. We talked about the abundant materials. It also provides some efficiency and safety, just as steel would in any case, but you can do what I would call more with less, which basically the strength to weight ratio of steel allows for you to span a longer length without a vertical column, things like that. So it really provides that design flexibility for intricate areas that are needed for or intricate areas where you're trying to build a bridge. The other thing that is kind of important to think about is it's a stockable inventory. You could stock common parts like guardrails and things. And if you had one damage or had to be taken out, you can have another one ready to just go right back up in its place. But one of the best examples of galvanizing versatility is the last case study that I want to show you here. And this is kind of a 2-for-1, if you will. So this is the former Fore River Bridge in Quincy, Massachusetts, that was put in 2002. The existing Fore River Bridge had some serious damage and I believe was actually closed to traffic because of the damage, or they needed to close it down because it was not safe anymore or couldn't pass inspection. But of course, this is a common byway and it was very necessary to have the connection there. So they use an acro structure again to put up a temporary bridge to bypass this area until the permanent structure could be constructed. And this was in place for about 15 years. So it gives you an idea of how long it took them to decide on a path forward, demolish the existing bridge and build the new. And if it weren't for this temporary structure, that would have been a very difficult 15 years for the folks in the area. But what's even more impressive about this particular structure is that in 2019, when this bridge was no longer needed and was going to be deconstructed, J. Cashman, which their headquarters is right next to the edge of this bridge, basically decided to take all of the steel, instead of having it trashed or recycled or demolished. They actually took all of the steel pieces that you see here, brought them onto their yard next to the bridge, and are now reusing the steel to build bridges for underserved communities free of charge. So let's take a look at this video that shows where the new life of part of this Fore River Bridge is now. See if my video will queue up for you here.
name is Jay Cashman. I'm the chairman of the board of Cashman Companies, located here in Quincy, Massachusetts. The company was started by myself in about 1970 when I was in high school. Over the years, we built it into a multidisciplined, heavy civil, marine, dredging. Yeah, well, we had basically done the demolition on the Fall River Bridge project, and there had been a Acro Bridge there for many years. So we had the demolition contract to take down the temporary structure and the remnants of the former bridge. The project was actually next to our headquarters. I kept looking at this bridge and I said to myself, we have to find some sort of repurpose for it. It had been scheduled in our estimate to just demolish it and send it to the junkyard and to get the value of the junk. It was amazing. Big, very heavily trafficked bridges were made of these structures, which I had like 2 miles of. And I think it takes a lot of courage to actually get down there and get your hands dirty, which, you know, going down to Haiti and seeing people in poverty, and maybe an abject poverty, is greater poverty I've ever seen in the world. And I said to myself, okay, maybe this is what I'm supposed to do. So off we went.
My name is Liz Turchia. I'm a project manager at J. Cashman Inc., and I am the co-director of the Cashman Family Foundation. They came into possession of all of this several thousand linear feet of Acro Bridge, and in deciding what to do with it, we thought the best thing to do would not be to scrap it, but to use it again, because it does still have, it's still totally serviceable. It has a lot of life left. So through our connections and our friends who already do work in Haiti, we got connected to some parties down there that are interested in infrastructure development, and helped us to sort of develop the concept for that became the Cashman Family Foundation.
You know, we're really kind of looking for places that will never end up getting any attention. That's kind of my goal at this point, is like Purge. That was on nobody's radar, and Liz found that opportunity. They've helped me navigate the social, economic, political dynamic of Haiti, which is, let's just say, it's complicated. At the very least, it's really complicated. Nobody's ever going to help these people, and this is something that I can really feel that we accomplished something. You know, one of the compelling reasons to promote this program or to keep these bridge sections as they were was the fact that they were galvanized. Even after 20 years, there's very little lamination, there's very little oxidation that's taking place. The galvanizing stuck on it. Whoever did the job did a really good job. These bridges, they're just as good as they once were. Generally speaking, I think that they're in excellent condition. It's amazing. You know, I'm familiar with galvanizing from back in the 60s when I first started building bridges, and everything had to be hot dip galvanized, and it wasn't that way before. And piers and you know, all the bolts that we had were galvanized. You know, we can go back to projects that we did decades ago, and you can still back those bolts off. And the fact that if I was concerned about that galvanizing, I would have basically just sandblasted and repainted it. Okay, I'll re-galvanize it, whatever, but the galvanizing was good. I think that they'll get another 30, 40 years out of this thing without really much in the way of maintenance at all down there. My experience with galvanizing, you know, over the years, particularly around marine structures, you know, and it really kind of changed the world.
So that's kind of the end of my presentation. I like to finish it off with that video because I think it really shows the opportunities for temporary structures and the reuse of galvanized steel. So even if you were to put in a structure that you only needed for a few years, if you build with these modular structures that many of the manufacturers of the Short Span Steel Bridge Alliance can provide, it's easy to reuse that in a new location each time that you have a new need. So with that, I'll open it up to any questions that you may have for me.
Okay, thank you, Melissa. That was very interesting. So during these 2 days, last Friday and today, you saw lots of benefits for these temporary steel bridges or even permanent steel bridges. But of course, finishing out with Melissa, one issue is that, you know, low carbon black steel has to be protected. Galvanizing is an excellent way to do that. There are more or less 5 ways to protect that steel, right? 2 of them are durability solutions from chemistry of the steel with weathering or even a stainless steel. The other 3 are applications, right? Galvanized steel is one of them, metallized, which is very similar, or painting. And there is not any one of these which is always better than the others. I know Melissa would disagree with me on that, but you know, performance for the particular bridge site, initial cost, maintenance, longevity, and even life cycle costs should be considered when choosing a protection method. But galvanizing is certainly a good one. We do have a question, but Melissa, what is the largest tank in the U.S. right now?
The largest galvanized kettles in the US right now are 60 to 65 feet. But we didn't talk about this today, but one of the things that's commonly done in the bridge market is you can do what's known as progressive dipping, which would be to galvanize, hang and dip one side of the steel and then turn it around and do the other side. So you can virtually galvanize a piece almost double the length of the kettle. But as Glenn mentioned before, oftentimes if you can build in a modular system, that is preferable because there are additional stresses to the steel when you use a progressive dip. And if you can avoid that by building modular into sizes that can fit into the kettle in one pass, you can avoid those additional stresses.
Thank you, Melissa. Okay, Joel actually, Joel would like you to address something. Can you address common misconceptions some engineers have regarding the environmental effects of galvanized structures on fish habitat? Which you know is very important to me, and nobody today showed a fisherman in any of their pictures, but we'll let that go.
Well, I have another video that you can watch on the Stearns Bayou Bridge, Michael, and you will see a fisherman on top of the bridge on that one. But very good question, Joel. And I know you and I have had conversations about this a number of times, and particularly this question tends to come up in the Pacific Northwest or the West Coast. And basically there's a misconception in the, I guess, in the specifier community, if you will, that zinc is a toxic element that when you put a bridge over a water structure, it gets into the water environment and it hurts the ecosystem of the water. It is true that if you put a galvanized bridge over water and it rains, there's going to be some zinc that washes into the river. There's no question about that. But one of the things to remember is that zinc is an essential element that is required for all living organisms, including fish. So it's not toxic to them except in very, very high levels. And we actually have a white paper that discusses the background levels of zinc in various different waterways throughout the US. And we show basically that even if you had multiple galvanized bridges over that river, and we had high rainfall, we can show you how much additional zinc is washed into the river and whether or not that would be detrimental to the fish life. And basically in no instance is that the case. And that's even assuming kind of the worst case scenario where all of the zinc or any zinc that would be, or zinc byproduct, I should say, that would be washed into the river would be what is known as, quote, bioavailable, which is not actually how things work in the real world, because, you know, they would be, those zinc byproducts would connect with other things and form other compounds, which would not allow for the zinc to actually be bioavailable for the fish life in the area. So this just basically stems from data that was very old and incorrect and did not look at the original background levels of zinc in an environment, and then measured zinc in a particular area, and it was elevated from a different area nearby, and they thought that it was the galvanized steel that was elevating the zinc. But what they had failed to do was basically look at the background levels of zinc in the environment prior to, which varies greatly throughout the country. So that's just a short and dirty version, I guess, of addressing that comment. But we do have an entire white paper called Zinc in the Water Environment that discusses that in great detail.
Okay, great. Thank you. We have a couple good questions here. How does galvanized steel perform when you have a gravel wearing surface? Concern is abrasion.
Well, as we talked about with the abrasion resistant galvanized steel, the layers of the galvanized coating are actually harder than the steel itself, and it is metallurgically bonded to the steel at about 3,600 PSI. So it's pretty difficult to actually damage the galvanized coating. I mean, that's one of its advantages. I mean, I've seen, you know, people take pieces of rebar and drive over them with a forklift or bang them together, and you're not going to lose the coating from that. So yeah, you may see some scratches on the surface a little bit. Basically would be scratches of the byproducts that are forming, but it would not be enough to damage the coating, just as, you know, driving a galvanized steel bolt into the ground doesn't lose the coating. So it can withstand quite a bit of force and torque without hurting the coating.
Okay, and now the tough one, the thing that concerns all people. How does road salt affect the galvanized steel? Any corrosion?
Well, as we all know, road salts are very damaging, or can be very damaging to steel structures. And, you know, the advantage of galvanized steel is it provides a little bit more protection than a bare steel or painted steel. And if you remember the 8 Mile Road project that I talked about, those bridge rails there had been originally installed in 1955 and taken down in like 2010. And that was over 55 years in Michigan, where they put road salts on the road regularly, where they pile up snow onto those rails when they plows come through, that sit there sometimes for months with salt and sand in the snow. And they still lasted, as I mentioned, for like 55 years without corrosion, and were able to be stripped, regalvanized, and put back in place. So yes, road salts are always a concern, but galvanized steel is basically built to withstand that. If you just had, you know, salt sitting right on the steel forever and it didn't wash away, of course you're going to see localized corrosion in that area. But as the way things work in the real world, of course, those are there temporarily, but washed away as new snowfall comes, or rain, or by vehicle traffic moving it around. So as long as it's subjected to those normal wet and dry cycles, it's not going to accelerate the corrosion significantly.
Great. Thank you, Melissa.
Yep.
And with that, I think we're going to close out today so everybody can start enjoying their weekend. I want to thank everybody for joining us today for the Northeast Council on Forest Engineering webinar. It was a pleasure coordinating this with Ray and getting you this information. I'm showing that last slide again. We encourage you to visit the shortspansteelbridges.org website, where you will see Acro and Contec and many other bridge manufacturing firms. You will see the AGA and galvanizing information there, but so much more. It is a great resource for your bridge engineering needs. And with that, Ray, do you have anything to close us out with, or are we done?
For me, Michael, we're all set. I appreciate everybody's time and participation, and thank you to Melissa and Glenn for your presentations, and again, Michael and Dan for your cooperation. And we'll continue to be in touch, and this is probably not going to be the last one of these that we do.
Okay. Everybody have a great weekend. Stay safe.